Basically, there was a debate about the nature of the light. Like some of them believe that light is having a wave nature, and some of them give theories about the light is having a particle nature. So, first about the nature of the light, that Newton's give an idea about the nature of the light, and that his theory is known as Newton corpuscular theory. What he said that light is actually behaving like a particle, and every particle give a different sensation. That's why we see different color. Like example, if you see something is red in color, so why you're able to see that that thing is a red in color, so it is giving a particle, and that particle give a sensation of a red color. If something appear to be blue, then that is showing that the object is blue in color. So Newton suggests that the light actually travel from one place to another in the form of particles, and these particles give a sensation of a different color, and the combinations are there. That's how we see the objects. But experimental evidence was not there. Newton was not able to explain experimentally that what are these particles, the presence or the existence of the particles, he was not able to prove. And another thing, that his theory was influenced by the sound, because sound travel faster like in solid as compared to that of liquid, and liquid it is faster than gas. But so what he suggests that the light should also travel faster in solid as compared to a liquid, and a liquid it is traveling faster than gas. But practically it was proved wrong. As we know, light is faster in vacuum or a gas as compared to solid or a liquid. So that's why his theory was discarded, because he was not able to prove the reason for why the speeds are different in solid, liquid, and a gas. The existence of the particle, first thing, and the second reason was about the speed. Then, to support the wave theory, there were theories in between, but most authentic or the one which were accepted, that is given by Huygens wave theory. Huygens suggests that the light is actually a wave which travels from one place to another, and it can be reflected, it can be refracted. But because his theory was also influenced by the sound, sound require a medium to travel from one place to another. Sound is a mechanical. So he also think that the whole universe is made up of hypothetical medium, which is ether. Like the whole space, earth surrounding everything is having a hypothetical medium which is ether, but the existence of the ether he was not able to prove. So Huygens give an idea that light is having a wave, and the wave travel from one place to another, which can be reflected, refracted. But the wrong assumption from the Huygens was that he considered that the whole universe is having a hypothetical medium, which is ether. So existence of the ether he was not able to prove. Then the Huygens wave theory was further explained by Maxwell Planck. And what he suggests, that light is actually is not a, and before Maxwell Planck, there was a experiment you have studied in AS, that was a Young's double slit experiment. The Young's double slit experiment, because Young double slit experiment, what it shows, we have two slits or two openings are there. When the light travel, it will diffract and it will interfere. So diffraction is a property of the wave, and interference is also a property of wave. Because wave can diffract, wave can interfere. So the Young's double slit experiment confirmed the idea and make them believe everyone that light is having a wave nature, that light travel from one place to another in the form of wave, And why they are sure that the light is wave? Because of the Young's experiment, that he suggests that like he did the experiment and his experiment result prove that there is an interference and there's also a diffraction. Then this concept of the wave, so now they believe that the light is having a wave nature. So the Planck's theory was there that light is not a normal wave. Light is what? Light is electromagnetic wave. Electromagnetic wave means it can travel through a vacuum. It does not require a medium, and the speed of a light, which is 3 into 10 power 8 meter per second, and the energy carried by the light is given by a formula E is equals to hf, where h is a Planck's constant, or if I know the wavelength, so E is equals to hc over lambda. So either I can use E equals hf or I can use E is equals to hc over lambda. So because first the Huygens gave a wave idea, then wave idea was in like only drawback with the Huygens was the existence of the ether, which he was not able to prove. Then there was experiment done by the Youngs to show that the light can diffract and interfere, which confirmed the evidence, like this give an idea that the light is a wave nature. Then the Maxwell Planck suggests that the light is basically not a normal wave, it is an electromagnetic wave. Electromagnetic wave means it can travel through vacuum. It does not require a medium to travel from one place to another. Then we have a famous experiment about the Einstein photoelectric effect. You will learn in detail about the photoelectric effect in this topic. What is a photoelectric effect? Photoelectric effect is basically, this was done by Einstein, and there's also a photoelectric equation that when we have a metal and the light falls on the metal in the form of a particle, it is that particle is absorbed by the electron, that particle absorbed by the electron, and electron will go out. So the Einstein photoelectric equation or Einstein photoelectric effect can only be explained by a particle nature. Wave nature cannot explain this photoelectric effect. So only the particle nature can explain this photoelectric effect. And we will discuss why the particle can explain and why not the wave explain this photoelectric effect. And so now some of the theories support the wave nature and some of the theories support the particle nature. So de Broglie combined all these relations. So there is a theory which is known as de Broglie. What he suggests that the light is having a dual nature. What is the meaning of the term dual nature? Means some phenomena can only be explained by wave nature, some phenomena can be explained by particle nature, and some phenomena can be explained by both particle and the wave nature. So, like example, reflection. Reflection, particle can also reflect, wave can also reflect. So, reflection can be explained by particle nature. But when we say diffraction, diffraction can only be explained by a wave nature, particle nature cannot explain diffraction. Same thing, photoelectric effect can only be explained by particle nature. It cannot be explained by a wave nature. So what is the nature of the light? What is the final conclusion about the light? That light is having a dual nature, means it can act like a wave, it can act like a particle. And what is the de Broglie relation? That lambda, which is for wavelength, is equals to h, which is a Planck's constant, divided by p, which is a momentum. So the wavelength is equals to h over p. So this is because this equation is having two different categories, like it is relating a wavelength and the momentum. So if there is a wave, because wave cannot have a momentum, but if this wave was behaving like a particle, it will have a momentum. So if I know the wavelength of a wave is 3 meter, so what will be the momentum? So if I need the momentum, it will be h divided by lambda, where h is a Planck constant and lambda is a wavelength, so I'll get a momentum. So equivalent particle I will get for that wave. So for a wave, it can act like a particle. For a particle, it can act like a wave. This is known as the wave particle duality or the dual nature of the light. And it's not about the light, it can also be for any electromagnetic radiation. Specifically, so means the particle can behave like a wave or a wave can also behave like a particle. Is it clear?